Hey, what's going on? And there is another episode of the, you know, basically trying out improving mathematical skills using KhanAcademy. If you're not familiar with KhanAcademy, it's pretty much a tool that allows users to go on and practice virtually anything they want. Mathematics is something I'm working on because I'm preparing for um, to work on more, I guess, more advanced or college level math skills, and being able to, to do simple calculations, or at least being able to remember all of the cool ways of solving these simple calculations are important for, any type of like uh, engineering, science, technology learning. So let me see if I can go ahead and share the screen. And okay, and all right. So for during this time, I'm going to remove the screen. We're gonna put this in, and so now I can have the camera and the phone. I mean, the iPad here. Okay, good. So, oops. So what I'm doing is, yeah. And so what I was basically going over is reduced student division. What's the multiplication? Yeah. Oh, I'm in the wrong one. It's decimals. Yeah. Okay, so we went ahead. I was like going over these things, but we're just gonna focus on the grid here. All right. So here the figure. The figure is not a scale. You have 2 times 40, and you have 0.7, and you have this piece right here. You can just, this is going to be 42. Here is 5, so 5 is here as well. And here's 0.7, and this all is 2. And it says, what multiplication expression could this area model above represent? And it says 45 times 27, or 45 times 2.7. And it says, we have here 2.7 times 40.5. And it says here 40.5. So let me see. If we added this whole thing up, this would be 45. And then if we had here, it would be 2.7. So it would be 45 times 2.7. So 45, 2.7, we have this one here. Oh, no, I mean 2.7 here. Yeah. Okay. Oh, I don't hear the sound from the, I want to have the sound come up. So you share computer sound. Okay. Next question. So the entire figure as a whole, what multiplication equation best represents this figure? So if we go ahead and we make sure we are paying attention, we have these is probably is 10 here. So it's 10 by 10. So here we have a 3 by 3 square right here. We have a 7 by 3 square, and here we have a 7 by 7. So here would be 49, 21, 9, and I guess this whole thing would be 100. And looking at this piece right here, we have a 7 by 3, so it's 21 is basically not there. So what is saying, which multiplication equation best represents this figure? Is it 0.21 equals 0.3 times 0.7? Let me bring this up here. And it says here 2.1 equals 0.3 times 0.7. So we're looking at 7/10, and we're looking at 3/10, and this is 2.1 tenths. So going back to the things that it says that which one of these basically accounts for the whole. So we probably won't really work with these because these are hundredths. I'm going to push that out right now. We have 2.1 is 0.3. Probably don't want this. These look a little bit better because each one of these would be considered a tenth. And so 7 times 3 would equal 2.1. But we can't say 2.1 because this is that means that this is a fraction. 7.3 would basically be 2.1 because of the fact that we're not counting the whole. The whole 100 would basically be 1. So that makes sense to me. And we're going to go ahead and we're going to use it. Final answer. Here we go. Okay, so move to the next one. You have here 8 by 10. 8 times 10 here is 80. Well, no, let's not do that just right. Let's read the instruction first. It says, what multiplication expression could the area model above represent? So if this is 10 plus 9, that means 19. That means 19. And then you have here 8.3 would be 8.3. And then that would mean that this side is 8.3 because these are even. And this is 19. So then it says, what did this expression could the area model represent? So 8.3 times 19, this makes sense because that would mirror area is length times width. And, then we have the length of the square, the length of the rectangle is 19. And the width, depending on how you're looking at it. So it's going to be this answer. These are very simple, compared to what you're doing. But I like being able to make sure I understand the basis of what I'm trying to do before I start going into it deeper. Okay, let me just bring this up. Okay. So each large square is equal to one whole. So the large square they're referring to this each large square. So there's 2 large squares. And then each square, a square equals one whole. So a square equals 1 and square equals 1. We even say this too. And now we can look at the answer. We look at the pieces here. So we know that once again, that it's 10 by 10. Each one is 1/10. And then you have here is 1, 2, 3, 4. And then you have here is 6 and 4. So what we're doing is that we're looking at 46. And then you have here 1, 2. And see, so you have 1. Let's look at this one here. 1, 2, 3, 4. We have 40 again. This is 44. So we could say this is 44. I'm going to change the number to 44. And we have here is 1 to 2. So this is 8. And then this side we have 3 plus 8. So this is 38. Then that means if that's 38, then that means that this other side is 42. No, wait, 1, 2, 3, 4, 5, 6, 662. Okay. And, basically equal 100, the whole thing. So now we know that. So now we can say what best represents the figure. So we have 3 times 4.6 and 4 times 0.36. So the idea is we can go here and we can look at to see which one. There's only one answer. One of these answers has to be right. So it looks like it says 1.38. This is basically what we are. 138. One, 3. Wow, I can't. Okay. Yeah, so 138 is definitely the answer. but we want to describe on which one each one is. Looking at our numbers here, it looks like we're adding this colored shade to this colored shade. So going back to what we have here, this is 46, and that's 38. We have 46 plus 38, and then we have here 44. And I'm confused. Yeah, it's 46 plus 38. That sounds so weird to me. If oh, let me see something real quick. It's 1096. Oh wait, 6. Oh, okay, wait, 1, 2, 3, 4, 5, 6. And then you have here 1, 2, 3, 4. So that's 46 right there. And then you have here is 1, 2, 3, 4, and then you have this 46. So it's 46, 46. Let's go ahead and add a different color. This is 40, 44. This is actually 46. And then we have here would be 8. So then we can add this to 8. I'll leave that alone. So that would be 46 plus 8 would be 54. And then you have 46 plus that would be 100. So that means that's equal. So then we have this side here, which is 38. So let me see if I add this with here. It's 92. That's not it either. So let's go back. Yeah, let's go back to that. Okay. And we can erase this. So what I'm basically trying to do is trying to make sure I break everything down into very small pieces. So that way there's an understanding of what I'm trying to do before I actually to do it. So of course it's asking me right now, it's saying 3 times 4.6. So what is that? Where are they actually, where they're actually going ahead and doing it? It's a little bit confusing. If this is 38, and then this is 138, they're saying 3 times 4.6. I don't even understand. Well, let's break it down. If 1, 2, 3, 4 would be, that would be 0.46, definitely. And then you have 3.46. I don't know why there's the colors there. Because if we have 3.46, maybe we can just go ahead and check out a hint and see what happens. It says number of groups and group size equals total. 3 small groups equals 4,600. These 3 equal groups of 4,600. Okay, so that's basically what we're doing right there. We're looking at the groups. So it's 1, 2, 3, 4, and then that's 46. So this is 46. This is 46, and 2, 3, 38, 39, 40. 1, 2, 3, 4, 5. Oh, see, now I see what happened. I don't know. I was actually looking at that the wrong way, but it was. I guess they did this. This color is just set up because they were trying to show different groups. So now we know that there's 3 groups of 46. Now we can say that it's going to be 3 times 46 because each group is 46. Yeah. Okay. Yeah, that was kind of weird. Okay. Let me move on to the next one. Trying to multiplying decimals. Work on that real quick. Okay, so we have here 165 times 93 and that equals 15,345. And 165 times 93 is 15,345. And they're saying that's what it is. Now we want to match the expression with the product. We gotta look at these little weird numbers here. So okay. So they're saying basically that if we see that 165 times 93 is equal to 15,345, then we should be able to find out that which one of these products match each product with its expression. So what I like to do when I start doing something like this, then let's go ahead and start with a very simple situation. This one is pretty much like that. Okay, so the next one, if we go ahead and we do it, we say 165, we put a point here, and we put a point here, and we put a point here like that. Then what we get, we don't have to, we moved it just once, we moved it once to the left. So you would, the numbers would still come out, but we probably would just move one to the left. So for example, here is 16.93, 0.23. So you probably would get this one here and put that there. Now, 165 times 1.53, that would basically be 165, and you have 9.3. I'm going to put a 0 here, so that way we would know that these pieces, this is right. Yeah, like that. So that way we would know where everything is when we line them up. So here would be 9 times 33. So we probably would only get 1, 2, 3, 1, 2, 3. So we're going to put that here, 15.345. Reason why, because I'm doing it is because we have to times 3 by this. Every time we point 3 by those 3, they end up on this side of the denominator, and that leaves us with 165.93, and that's here. 165 times 9.3. So now we have something like this where we line the numbers up. So now we have 1, 2, 3, 4. So this would probably, is that right? 9.365. Yeah. So it probably would be this one by default. I feel like my Price is Right. No. I mean, I could just go ahead and do all the calculations, but I think that I'm actually, now I'm going to try to see if I can just, this one, yeah, only because this is only one, it's $1.65 times $9.30. And, 9 times 1 would be 9, right? But because we have this, we're timesing 65 cents by 30 cents, we're going to get a lot more. but since they're all, small, it might go up a little bit more, which this probably makes sense looking at that. And here you have 165 times 9.3, which was just 9 times 165. That large number is going to be there. And then you have, what do you call it again? We have, basically, what we have here is the 16.5 times 9.3, which is 153.45. And that's probably just like 9 times 16 is great. So what I'm looking at is that as the larger, as the whole number gets larger, we should expect a larger number. And as the expression, as the fraction, or the whole number that basically has a decimal, and we multiply by decimal, it gets smaller. We should actually end up with a smaller number. And this is kind of like where that was the intuition I was trying to actually get. And I was very confident with that one. So that makes sense to me. So moving on to the next one. Let's go ahead and let's add this. Okay. It says Molly knows that 45 times 811 is 36.95. But then now you want to understand how to solve 4.5 by 81. Now, remembering what we said before is that this is pretty much like $81 times $81.10 times $4.50. Or so we can. I would like to look at it as $4.10, $4.50 times 81 times. So if we look at this from one standpoint without looking at this, we would know that 81 times 4 times 1 is 4. This is 4. This was 20. 32. 8, 16, 24, 32. So that's basically one thing. But now we have 50 times 10 times. That's like 2 quarters. You get 2 quarters 10 times, which would be like $2 extra. Or so it's basically half of that, which would be like $5. So if you add that 5 times 7, you would probably run up with like that little number. So let's go ahead and move this out. And let's look at 364, 950. So we know that 4.5 or 81 is a small number, meaning it's smaller than 811. So we should be getting a smaller number. Since this is 3765, we wouldn't get 364,000. We wouldn't get that number either, And because this is kind of like, this is exactly like this. That's kind of like what we see right now. Now, this is not how I normally do multiplication, so I wouldn't do that just yet. But like knowing we have this allows us to take advantage of things like that. So we have next one, 4.5 to 8110. So 3.64 times 95. And so we went back to this one is pretty much closer to what we want, because we know that 81 times 4 gets us 324. So since we know that this is pretty much closer than that. So without having to do any of the multiplication, I'm gonna try that. There we go. Here's the next one. All right, so here's 8,000. It's 8,923, and you times it by 6, and we know we get 53,538. So that's a pretty big number for a digit that's pretty close to 10,000. It's approaching 10,000. So now we know that if we get what's the second smallest number would be this, and this is the largest number. This is the second largest number. This is the third largest number. So 1, 2, 3. Large, small. So what I'm trying to do is I'm trying to say, as we're approaching, as these numbers get bigger, our number gets smaller. That's kind of like how I'm looking at it. So we know that, and we know that largest number we have here is this one. The second one would be These two are both the same, but the number that they're charging is bigger. So we know if we go ahead, this will be the smallest. Mainly because it's like saying 60 cents times 89 times, This is $6 times 80 times. This is bigger. This is a bigger number. This is like 6/6, and this is like 6/10 or 60 cents. So now that we know that, now we know we can probably put together our numbers properly. So we know that the largest number will probably be here. This will probably would be the second one, which is right there, $535.65. That makes sense because of the fact that if you have 80 times 5, think about that. If you have 80 times 5, it's 400. So it can't be this, and that's how we can solve that without having to go too deep in it. That I feel more confident with it actually doing these little mathematical calculations. So you have 65, and you have here times 4,903, and we know that that is at least 318 by 695. So now we know. Remember before, my little calculation that one is large, this is small, and then we have here choose one, to help us understand Julia 6.5 times 4. So we want to know 6.5 times 4,093. So since this is pretty much a tenth the size of this, 10%. So like when I'm saying that, if you say 65 times 10.10, it's pretty much 10%. So that would basically be $6.50. That's 10% smaller. So we should assume that we will probably have a number where we have a discount of 10% less of that. So 10% of this. Basically what we want to do is we want to find out 10% of that. I don't want to multiply that, but we know that if whatever this gets us, we'll be able to get. We're going to get a small number. We know that. How would you basically say it? What we do if we do this? So we know 300,000 is going to be 10% of 300,000 is I think like 30,000, and 10% of 300 is $30, and 10% of 3,000 is isn't. Am I doing it right? 10% of 3,000. I think that's 300. Yeah, I think I actually mixed it up. 10% of $30. Yeah, it's 30. 10% of 3,300. Yeah, 10% of 3,300. So we notice that as we get bigger, we get that. So this is about 30,000 something, maybe 30,100, something like that. 31,869.5, maybe that. So yeah, so that's basically where that is. So we can look at that. Since we noticed that, we could probably go with this because this is 10%. So it can't be this because that's not 10%. That it can't be this. It can't be this. So this is probably a good way of thinking about it. Like I'm about maybe like 70% sure with that, mainly because of the fact that I never really looked at it that way before. But like this intuition helps from me learning math, all the way into calculus too, and coming back to here and trying to play with the numbers in a more fun and exciting way, rather than looking at it like it's miserable. So it's not. I'm pretty sure with that. Mainly because of the fact that this is pretty much the same. This is the same large number we have here, but now we're just looking at it from 10% of the value of it. And because 10% of 318,600 is about 300, it's about 318,000, we might be able to. No, yeah. I'm sorry. I'm supposed to look at this. 300,000 times 10% is 30,000. So we have the only one here that is actually like within like at least 30,000 is this. Now, the only thing about that I'm a little bit worried about is that I'm actually multiplying 10%, and this is actually 6.5. So that's like a little bit half than that. So what would be half of 30,000? I mean, like for 15,000, you know. But and then if you have a little bit more than that, would roughly be maybe, I don't know, like another five, like 2 or 3,000. So without using calculations, I'm gonna try to use this one and see what happens. Yeah, I was right. Yeah, see, and it was actually good to start choosing it because I was starting to doubt it myself. I knew it was 10%, you know, but that's basically what that is. I'm curious to see 318,695 times that by, okay. Wow. Oh, okay. I get what I did. All right. So yeah, it's 10%. That is 10% of 6.5. So we don't have to worry about that. That's what I was doing wrong. It was actually, I had the number there times 10%. So 10%, that's basically what it is. But because it was 10%, right. So what happened was that because this was 6.65, 6.5 is actually 10% of 6.5, then our answer should be 10% less as well. So since our answer was 10%, 10% less, since our answer was 10% less, this would definitely be the answer because these other were way off. This is all right. Let me go ahead and continue. All right. I'm gonna try to do a few more because I know I think I'm already like in half an hour. Actually, I'm gonna stop. I'm gonna stop right now because I have other things to go ahead and do. Yeah. So that's pretty much what I'm doing. I'm kind of knocking those things down. The idea is to play around with the new mindset of like playing around these things. I really am believing that that playing with the numbers over and over again is great. Like just because if you probably did it before in the past, doing it again helps to reinforce what you learned before. And I was able to play around with the numbers because I was more confident, with the numbers than if I would have done it when I was like younger. And sometimes tests just stress you out, but that's kind of like why I'm trying to mimic the tests, like test taking in, with using a live stream. You see how I make mistakes, you see how I come back up with them. And I think this is actually a good thing to do when it comes down to dealing with failures helps you to do things better the next time. And if you are afraid of failing in public, it's better just to record it and let everybody see it, not just like, a small few people would see your failures. This way you get a chance to see that maybe your failures might not be the best choice for this people, but it may be the best choice for these people, and then you can grow from that. And that's kind of like where I'm going to go and end the actual talk for today. Thanks a lot, and I'll see you guys tomorrow. All right.